All right, here is a review for your last test. We didn't have time to do a partner test for this one, we just ran out of time. So instead, we're just gonna do our partner test together, I guess. The first two questions, the objective was, you were given functions that were periodic. And you were asked to state the length of the cycle. So they are periodic. Can you tell me how long a cycle is? Now, depending, I already heard the answer. Can anyone else verify?
4.
4. Jenna, are you agreeing?
Yes.
Yes.
Wait,
Now-
no.
No?
5.
5? What?
Wait, no. Hold on.
Now, these can be tricky. Can someone tell me to start somewhere?
I got 4. I started at the top of the peak.
Start at the top of the peak. Where? Right here?
Yeah, that one.
Okay, let's trace. Start there. Tell me when it starts again.
Oh, okay, yes.
Right there. Good. So let's count. So these, you want to make sure you read your x-axis. So from -1, that's 1 unit, 2, 3, he's right, 4. Good job. That's all you do. How about the next one?
4.
That is also 4. Well, how did you figure that one out? I went from the bottom here to the bottom here. Did anyone else do that? Yeah? That's how I did it. I went from the bottom, and I said, okay, from there to there. And I made sure that, because sometimes they go by 2s. So from here to, but these are going by 1s. These are going by 1s. They didn't number them all, but since it went every other one, these are each 1. So 2, so that's 1, 2, 3, that's going by, that's 4. That's the length of one cycle. Okay? Good? So that's one objective. The next objective was to determine whether the function was periodic or not. Because some functions are not periodic. And if it is periodic,
So is 3 not periodic?
3 is not. Good. It is not periodic. So if it is not periodic, we can't state the cycle. Is 4 periodic?
Yeah.
It is. Can you tell me how long that cycle is?
6.
How did you figure it out?
I started at the y-axis.
Me too. I started at the y-axis and I went to right there. So from here to here, that is 6 units. Good job. And this is what your test is going to look like. Just different problems. Okay, any questions so far? All right, next, 5 and 6. I need you to do me a favor. I need you to put in midline. Add midline. Add midline. Because we did midline too. All right, so you're given a periodic function. These two are periodic. The midline is a line, it's imaginary, and it's where is the midline in relation to your function? Anyone remember where the midline falls?
It's in the middle of the
Midline. Where?
It's like right in the middle of the.
Right in the middle. How do you think you would find the midline? Midline.
Did you do like the highest point minus the smallest? Or the smallest minus
Divided
the
by
highest
2?
divided by 2?
Okay.
Or did I say that wrong?
You're close. You're close. your highest, how do you find the middle? How do you find the average of two numbers?
Add them together and divide by two.
Add them. You add them. So what is the highest of, what's the highest number here?
4.
4. This is the highest number, 4.
And the
What's the
smallest
lowest?
is
Is -2. If you added these two numbers up
-2. 3, right?
and you divide that by 2, what do you get?
1.
2 divided by 2 is 1. So y equals 1 is your midline. Y equals 1 is your midline. So if you added the two numbers, the highest and the lowest, and divided by 2, think of average. Add them up and divide by 2, that's your midline. Your amplitude is how high off that line does your graph reach. What's the highest and lowest number? How high, how many units does that graph reach above and below?
3.
3. Now, if you wanted to figure it out mathematically, do you remember? And D'Angelo, you started to say it. You said, take the two
Oh, you
numbers.
subtract them.
Yes, that's where you subtract them. And that's where you're gonna get 6 over 2, which is 3. That's how you get that. So it's up to you how you wanna do that one. That's why I like to do midline first, and then I can see the amplitude so much better. Does that make sense? Okay, how about number 6? Okay, so make sure you read your graph. I want you to add midline. 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 So again, how do you find the midline? What's the highest number? 6. What's the lowest?
2.
2. How do you find the midline?
6 plus 2.
Mm-hmm.
5 plus
What do you get?
2. 4.
Mm-hmm. Y equals 4 is your midline. How would you find the amplitude?
6 minus 2
Mhm. 4 over 2 is 2. And double check, is that 2 units above and 2 below? Sure is. Good. Number 7 is a real world application. It says, the graph to the right shows the temperature change of a heating coil. Use the graph to find the amplitude and the period, and we can even find the midline. Let's do the midline too. So, can you first, let's analyze this graph. What is the period? Do you see the pattern? Now, I heard 4, but you're not reading the graph. The time is in minutes. Can you tell me where this graph, it starts at 0, and where is it starting again? Tell me where it's starting again. Right there, it's starting again. What is that? And then it goes here, and then here. So from here to here is one period. What is the length of one full period?
2.
It's 2 minutes. 2 minutes. It's very important that you be able to read a graph along the x-axis. It's 2 minutes. Everyone got that? Don't go by these boxes. You gotta go by the numbering. So from here to here, it's 2 minutes. That's the length of a period. Now, what if I wanted to find the midline? Now let's read this. So from here to here is 25 and 50 and 75. So what's the smallest number here?
75.
And then what's the largest?
175.
So how do you find the midline? Midline is what?
175 plus 75. divided by 2.
175 plus 75, and then divide by 2. What do you get?
125.
250,
125.
125.
$150, right? No, $250. Okay, and then how high off the x-axis is it?
50.
This is 75.
It's one above the 100. 125. Between 150 and 100.
So what's your amplitude?
Oh, you do 175 minus 75.
So what's your amplitude?
50.
It's 50. Next. Okay, next. Now we're going into section 13.2. I'm gonna give you an angle, maybe a very large, very small angle. You have to find all coterminal angles that are between 360 and negative 360. This is all you have to do. So, 830 degrees. You're gonna type 830 in your calculator. That's bigger than 360, right?
Yep.
So it's beyond 360, so we're gonna subtract 360. And I get, my first angle I get is 470.
You guys subtracted again.
Yes, if I subtract 360 from this, I get 470. That's still beyond 360, it's too big. So that's not an answer. So I'm gonna subtract 360 again.
You get 110.
I get 110. That's a good one. 110,
And you can do it again and get 250.
Uh-huh.
Minus 250.
I'm gonna subtract 360 again. And is that negative 250, does that fall in between here?
Yes.
It sure does. Now, if I were to subtract another 360, it's gonna be beyond negative 360, so I'm done. Now, negative 244. Is everyone with me on that? Negative 244. If I type negative 244 here, sorry for the glare. Negative 244. If I were to subtract negative 360, what's gonna happen? It's gonna be bigger than negative 360. It's gonna be negative 600, right? So now I'm gonna go the other way. I'm gonna add 360.
You get
Add
116.
116.
I'm gonna get 116. Now, if I were to add another 360, it's too big. So this one only had one answer. So I'd give a point for that and 2 points for that. Okay, now, take your unit circle that Mr. Duke passed out to you. All right. See this right here? This is your x-axis. This is your x-axis right here. If we go this way, we have a positive angle, right? How much are each of these quadrants equal to? 90. So can you count by 90s? 90, 90, 90, and 90. So if I wanted to graph negative 245 degrees, going backwards that's your negative angles. So if I go backwards negative 200 and whatever degrees, this would be negative 90 degrees. From here to here is negative 90. Okay. This would be negative 180. and this would be negative 270. So where would you draw a negative 245 degree angle?
45 in quadrant.
It would be like this. This is all you would have to do for me. Go this direction, just like that. Just like that. So going negative, it's in that third quadrant. Because each of these is 90 degrees backwards. That's all you have to
What
do.
is that little symbol thing? Is that like a triangle or something?
What do you mean, is it?
It's like.
It's an
like-
arrow. It's a direction. You're going, here's your X and Y axis. You're going from here, you're going that direction. And you're landing somewhere in this area. This is your terminal side. You're starting here and you're ending here. This is telling you your rotation. You're going in this direction. Okay? Now for this one, 320, you're gonna start on this axis. You always start on your positive x-axis. Now where is 320 degrees? Now we're gonna go the other direction.
It's in quadrant 4.
It's in quadrant 4. So you're gonna go, you're just giving me the direction. You're gonna just do this for me. I just basically wanna know what quadrant, bless you, like that.
That's it.
I just want that arrow, that. I'm going in this quadrant, in this direction. I'm starting here, and I'm going in that direction. Where's 240 degrees?
Third quadrant.
It's in the third quadrant. It's between 180 and 270. So you would do this. Like that. And D, where is negative 270?
On the X and Y axis, positive X and Y axis.
Yep, it actually lands, because that's negative 90, negative 180. It actually landed right there. This is negative 270. Questions? So basically knowing that unit circle, you should be fine. Number 10 is gonna look just like number 10. So just memorize this problem. Can you label these sides? If you have a 45, 45, 90 triangle, can you name these three sides? Everybody better.
Isn't it like
One
1
square root
1
of 2.
square root of 2?
Everyone can do that, right?
Yeah.
How about this one? If this is 30, what's this side?
Only 1, 2 square root.
1, what's this?
2.
2.
Square root of 3.
Now, I did a big boo-boo. Does anyone see anything weird with this triangle?
Isn't square root of 3 supposed to be on the hypotenuse?
I'll tell you what my boo-boo is. Lauren, I think, sees it.
So that's-
Your longer side, my triangle, I goofed up. It should be, and I will fix it. I should have made this 30, and I should have made this 60. My triangle's not drawn correctly. You see it? Your longer side should be, it should look like this. See this is your shorter, it's your shorter leg, so I should have made that 30. This is your longer leg, this is a bigger angle, this is a bigger side. So I didn't draw it to scale.
So that
So
long side.
this should have been 1. If it was drawn to scale, this should be your 1, this would be your 2, and this would be your root 3. So I'll fix it. but just so you understand, the side opposite the 30 is the 1. Your hypotenuse is double, and the side opposite the 60 is root 3. So that's what it'll look like, okay? So let's fix the other ones on the back. Okay, number 10, the first one's okay. Did I call them all 10? I guess I did call them 10. All right, now I'm actually putting in numbers, and I want you to fill in the sides. Fill in the blanks.
You said the hypotenuse is double the other one. So
Well, in a 45, it's not double.
okay.
What's the hypotenuse on this one?
Square root of 5.
5 root 2.
Yep. 5 root 2. What's this side right here? What do you know about in a
5.
45?
1 square root of 2.
This would be 5. In a 45, 45, 90, your legs are identical. Your legs are identical. Okay? Yes or no? Yes, yes, yes? Okay, for this next one, quickly fix, switch, make this your 30, and make that 60. Now it's drawn, now it's better. Okay? That's the way your triangle should look. All right, so we've got a 30, 60, 90 triangle. My hypotenuse, it says, is 16. What do you know about the relationship between the hypotenuse and the shorter leg? Which is the shorter leg? Is it this leg or this leg?
The first one.
The bottom one.
This one right here.
So then
The
it'd be
leg opposite the 30 is the shorter leg. That's why when I first did it, it was wrong. What's the relationship between the hypotenuse and the shorter leg?
Hypotenuse is
It's-
double.
Yeah, it's double or half. So you want to do what with this?
Divide by two.
Yes, cut it in half. So what's this side going to be?
8.
8. And what's the relationship between the smaller leg and the bigger leg? These are your legs.
Isn't it just 8 root 3?
Yes, it's 8 root 3. Good job. 8 root 3. 8 root 3. This is stuff you learned in geometry. 8 root 3.
So why is it 8 root 3?
It's, if you go back to the day that it was proved, it was Tuesday. If you want to grab those notes, the proof of why it's 8 root 3, it's the relationship. If you want to, I can show you how to prove it. Why, the reason why, okay? But that was Tuesday. I'll go back over that with you. You have to do the Pythagorean theorem and all that. Okay, how about this one? Do you remember what to do when you have a 45, 45, 90, and they give you the hypotenuse and you gotta go to a leg? So let's talk about this. We went from a leg to a hypotenuse. We multiplied by the square root of 2.
Divide by square root of 2.
Travis, say it again.
Divide by square root of 2.
So now when you go from a hypotenuse to a leg, he's saying divide by the square root of 2.
That's it.
That's it. So it's 3. So when you go from hypotenuse to leg, you divide by the square root of 2, if it's a 45. If you're going from leg to hypotenuse, you multiply. And this one, and I need you to quickly switch, fix, put 30, 60, fix them.
So the shorter leg would be 4.
Let's make the smaller leg 4. Let's make the smaller leg 4. Smaller leg is 4. How do you find the hypotenuse?
Multiply by 2.
Yep,
So it's 8.
8. And then how do you find the bigger leg?
It'd be 8 root 3.
Not
Four.
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 4 root 3. 4 root 3. Okay, this now is the stuff that, the last stuff you learned. Now take the circle. I need everybody to fill the circle out quickly. We're gonna start with 0,
360.
360. Now go around. We have 180. I want everyone to fill your circle out how you would do it.
90.
90.
270.
70. And then 30, 60, 90.
I do my 45s. I add 45. And I remember that my 45s have a 5 in them. And I just keep adding 45s. 225, sorry. Right? 45, yep, 225, 45, and that would be 315. Okay, and then I do my 30s. 30, 60, 90, 120, 150, 180, 210, 240. Keep adding. If you add 30, you get 270, 300, I'm talking and writing, 330, and 360, so we're good. Okay, so I have my circle. Now, question 1. Remember, you're always thinking about that x-axis. The x-axis, that's the important axis. So question number 1. Holy moly, we have a 690-degree angle. Way too big. So what am I gonna do? I heard it, minus 360.
It's 330.
And what do you get? I get 330 degrees. Where is 330 degrees?
4th quadrant.
It's in, so take your circle. Where is 330 degrees?
Right there.
It's in quadrant 4. It's this circle right, it's all the way here. 330 degrees. It's in quadrant 4. What angle do you make with this axis? Remember, you always want to create an angle with the x-axis. See this angle right here, from here to here. So this is what I would do. I would draw underneath, that's why I left you some room. So tell me what angle this is again. It's 30 degrees. There's your right angle. Label these sides. The side opposite the 30 is 1. But I'm going to call this negative 1 because in quadrant 4, the y value is negative. The hypotenuse is double. Hypotenuse is always a positive number. And the side adjacent would be root 3. So now I need to know what's the definition of cosine. And remember, I'm always talking about the angle that I make with the x-axis. So what's the definition of cosine? Adjacent, it's this number over the SOHCAHTOA. So it would be root 3 over 2. Root 3 over 2.
Just as well.
Okay, next one, negative 240. I don't like going backwards 240. So I'm going to add 360 to this. Because I like to go from the x-axis, I like to go around I like to make a positive angle. So if I go the other way, I get sine of 120. Okay, where's 120 degrees? Here is 120 degrees. From here to here is 120. So what angle am I making now with the x-axis? How many?
45, 90.
What is this?
45, 45, 90.
No, from
30,
here to
30,
here.
60.
If I landed at 135, that would be 45.
Or no, 36,
30,
90.
60.
This is a 6, from here to here is 60. So I have, this is what I have. I'm gonna draw my angle. This is a 60. So this side is √3. This is gonna be -1, and this is 2. What's the definition of sine? Opposite over hypotenuse. Now, why did I call this -1 and this positive √3? Because in quadrant 2, the y value is positive. √3 over 2.
How do
They
you-
actually both the same answer.
How do you know which way to make the angle?
It's always with the x-axis. You were in quadrant 2. You landed right here. You drop your line with the x-axis. You are making a triangle in reference to your x-axis. Now, this next one is tricky. Where are you landing on this one? Where is 90 degrees? Right here. 90 degrees is right here. What's the name of this ordered pair? 0, 1. When you land on this point, or this point, or this point, or this point, you definitely need to know the definition of sine. Sine is the y value over the r value. Sine is y over r. Well, what is the y value here? It's 1, xy, xy. So it's 1, and I told you r is always 1. So the answer is 1 for this one. So the ones that land on the x or y axis, you have to use the definition. Go back to that definition page. When we did this, the notes, right here. We did sine is y over r, cosine is x over r, tangent is y over x. Okay, next one. Tangent, -120. I don't like that, so I'm gonna add 360 to this.
240
You get 240. Where's 240 degrees?
in the third quadrant.
It's in the third quadrant, so let's get our circle. Here's 240 degrees, right here. So, okay, everybody look at this, because you guys are not getting something here. So from here to here is 240. So you land right here. You're gonna take this, you're gonna reach the x-axis. So this is your triangle that you're making. This is the angle I'm referring to when I make my, I'm talking about this angle from here to here. So from here to here, I'm gonna draw my triangle. So give me this distance from here to here, this measurement.
60.
It's 60, yes. So I've got a 60-degree triangle. This is 60. So I'm gonna call this side -√3. This side would be -1, and your hypotenuse is always positive.
Why are those negative? Are they usually
Because
negative?
in quadrant 3, x is negative, y is negative, hypotenuse is always positive. So in quadrant 3, x and y are negatives. Now what's the definition of tangent? Opposite over adjacent. So it's -√3 over -1, or the negatives cancel.
Can we get like the tan and cosine sign on the test that I look at? You know what I'm saying? So if we get it.
The definition,
Yeah, just like the opposite over hypotenuse,
we'll see.
because that'll be easier.
Okay, how about this one, E. E. Forget that it says secant. Look at the 450. What's the problem with 450?
Bigger than 360.
Okay, what's the first thing you're gonna do?
Minus 360.
So I wanna see you do that. What do you get? What's 450 minus 360? 90. 90, right? Where's 90?
Zero,
It's 0, 1. Okay, now, this is the reciprocal of cosine, right? Cosine is x over r. What's the x value? So what is,
0.
what's the answer gonna be? Instead of 0 over 1,
Just zero.
It's just
it's
0.
gonna be 1 over,
1, 0.
you guys know what this answer is?
Wait, why'd you flip it?
Because that's what secant is, you flip the cosine one. This is undefined. You can't have, you have to flip, when it's, this is the reciprocal one of cosine. Secant is the reciprocal of cosine. So what I do is the cosine one, which is 0 over 1, so the actual answer is 1 over 0. And 1 over 0, you can't have 0 in the denominator, it's undefined. Cotangent. Where's negative 180 at? Where's negative 180? It's right here, it's going backwards. What's this ordered pair?
0, 1.
It's negative 1, 0. You went left 1 unit, up 0. Well, tangent, by our definition, is y value over the x value. That's the definition of tangent. What's the cotangent? X over y. What's our x value? What's negative 1 over 0? What's this? Undefined again. Can't have 0 in the denominator.
Hold on, you go back to that.
Yep. You just, it's
So
all
you flipped
definition.
it to x over y from y over x.
Because tangent is y over x. So the cotangent is x over y. So the x value is negative 1, negative 1 over 0 is undefined. I'm running out of time. I want to do h. Where's 210? 210.
Third quadrant.
It's where?
Third quadrant.
Third quadrant. What angle do you make with it?
30, 60.
30. So there's 210. That's a 30-degree angle. So what are you going to name this side right here?
1.
Negative 1. What's this side going to be? Negative root 3, and that'll be a 2. So what's the definition of cosine? Adjacent over hypotenuse. So this answer would be negative root 3 over 2.
Oh, snap.
Okay, how about this one? Sine of 315. Where's 315 at?
Fourth quadrant.
In the fourth quadrant. What angle do you make?
45.
Yeah. So this is a 45er. So give me these measurements. This is going to be 1, this is negative 1, and this is root 2. Why did I call this negative 1? Why did I call this positive 1? Because in quadrant 4, the y value is negative. So what's the definition of sine?
Opposite over.
Opposite, so this would be negative 1 over root 2.
And you get root 2 over 2.
Opposite over hypotenuse. And let's do one more. 135. Where's 135 at?
Quadrant 2.
Quadrant 2. What angle are you making with this? Once you pass quadrant 2, you gotta go to the x-axis. So this is gonna be a 45. Right? Name these sides here. One. Negative 1, good. And what's this? Root 2. Now what's the definition of tangent? Opposite over adjacent. So it's 1 over negative 1. Go ahead, shut up.